All right, everybody, Mr. Delcor back again with another remote learning session here. We're going to add to our notes here today. Hopefully, at this point, you've logged into Google Classroom and you've seen the PDF file for today's notes posted under our materials for the day. You're going to want to upload that to Notability if you haven't done so already, and follow along with me. We'll add to our notes. These notes will be helpful in your CK12 questions later on today, and also just studying, getting ready for quizzes and tests in the future. So if you haven't already, pause here and go upload these notes to Notability so you can follow along with me and complete your notes today. So today's topic is all about air pressure. Last time around we talked about the atmosphere in general. What is it? What's it made of? We're going to be talking about weather a lot in this unit. We really need to understand essentially what the atmosphere is, what it's made of, but also we're going to hear this term pressure thrown around all the time. Air pressure is really important in weather. So let's jump right in here. Right off the bat, we've got some familiar vocab we've been talking about all year. We've got density. And density we're going to define as the amount of matter confined in a given area. And in this case, we've been talking about density using this unit here all year, measured in, you guessed it, grams per cubic centimeter. We've been talking about that a lot, or grams per milliliter. Essentially, it's this measure of how much stuff have we fit into a certain area. Objects that are more dense have more matter crammed into the area than objects that are less dense. And we can think about these concepts when we think about air pressure, because we're going to be talking about how close these particles are together, and often the density of the air is impacted. So let's do this. Let's also note that air is most dense at sea level. And that's important to realize. When we think about our atmosphere, it's composed of a variety of layers, but the very lowest layer we call the troposphere. So if that's the Earth, and I zoom in, and we've got this bubble of air around us, and we're chilling down here at sea level. Here we are. The air is most dense around us down here at this lowest level in the troposphere. The air gets really not very dense compared to down here where the air particles are much closer together. The higher up you go in the atmosphere, the less dense the air becomes generally. So let's clear that out. All right. So let's talk about what air pressure is. Air pressure is a force. So we're going to call it the force exerted by the weight of Earth's atmosphere. And essentially, a lot of people have a tough time imagining this, but air has mass. It weighs down on us. And the more air above our heads weighing down on us, the more pressure we feel. It's identical to swimming deep in a swimming pool or a lake and feeling that pressure squeeze you because there's so much water above your head weighing down on you. The air is doing the exact same thing. We don't necessarily perceive it very often because our bodies are calibrated to kind of live here at sea level on Earth, where we experience a pretty steady pressure. So we measure pressure. We measure pressure in PSI, or another unit called the Pascal. PA is our metric unit for pressure. And this is an important thing to know. I'm going to put a star next to it. The average is approximately 15 PSI at sea level on Earth. Okay, so right now, sitting around here at sea level on Earth, we're being squeezed in all directions by the atmosphere, by the weight of the Earth's air above us is squeezing us at about 15 pounds per square inch. So every square inch of your body, 1 inch by 1 inch, is being pushed inward with a force of about 15 pounds. And you don't feel that because, again, your bodies are just calibrated to kind of to experience that. Now, the interesting thing is, remember our analogy again, if this is the Earth's atmosphere, and here's the Earth's surface, and we'll draw our little guy again. Here's our guy at sea level. Remember, here at sea level, I've got a whole bunch of air. I've got about 15 pounds of air weighing down on me because I've got the height of the entire atmosphere above me. Now, if I go higher up in the atmosphere, let's say I go climb a mountain or I go for a ride in a plane, right? So here we go. Here's my mountain. Now I'm standing on top of a mountain. Check it out. I've actually got less air above my head weighing down on me, and I'm going to experience less air pressure. And we all experience this in our day-to-day lives. As we drive around, if you've ever driven up or down a mountain, and you've felt your ears pop, or riding in an airplane, felt those ears pop going up or down, what you're experiencing is changes in air pressure affecting the gases in your ear, in your ear canal. So you can feel that gas expanding and escaping, or pushing its way in, depending on what's going on with the air pressure around you. So let's think about this. Let's apply our understanding of air pressure and how it's related to altitude, and let's think about what's going to happen. We'll fill in these blanks together. So if I'm going up a mountain, I'm driving uphill. If you've ever driven up and gained altitude, you're driving way up a mountain. As you go higher in altitude, the air actually becomes less dense. There's less air above your head. There's less air pressure on you. That means the air in your inner ear is all of a sudden more dense than the atmosphere. So you have, higher density air crammed inside your ear. The air around you is less dense. That means the air is going to force out of your ear through a small tube, and you feel that ear pop. It actually works easier if you're talking or chewing gum. As you move your jaw, you allow air to move in and out of those ear canals. So that's what's going on when your ears pop when you drive up a mountain. Now, when you drive back down the mountain, or when you come down to land in an airplane, as we go lower, the air is becoming more dense very quickly as we lose altitude. The air in our ear, which was last equalized way up high, is actually less dense than the atmosphere. And what's going on there is you feel your ears pop on the way down, is that air is forcing its way into your ear, because all of a sudden we're entering an area with higher air pressure as we go down in altitude. So that's all we have for notes today. I really want you guys to go back to Google Classroom and watch my YouTube video I made for you guys. My kids are in it this time around, and it's pretty comical, but it does a really good job illustrating just what air pressure can do, and it illustrates the fact that there is air pressure around us. I'm going to crush a can in my kitchen using only air pressure, and you'll get a little preview of how I do that here. We're going to take a can. We're going to put it on on the stovetop with just a tiny bit of water in there, and we're going to get it really hot so that the can is full of water vapor as the water boils. And what we have there is lots of water vapor in there, tons and tons of those particles expanding, moving very quickly, escaping up out of the can. And then I'm going to take that can, I'm going to flip it upside down into a bowl of ice water, in this case snow water from our snowstorm the other day. And when that happens, those particles are going to cram together very quickly as they cool off. And now all of a sudden there's less pressure pushing outward on the can than there is pushing inward from that 15 pounds per square inch of our atmosphere. And you're going to see that can actually crush itself. And it's going to be the air in the room crushing the can, which is pretty amazing to think about. Now, I posted another video there as well of a science class crushing a 55-gallon steel drum doing the exact same thing. It's the same experiment you're going to see me do in my kitchen, but it's just on a much larger scale. Really, really cool stuff. So I really hope you finish your notes up today and you go and check out that video I made for you guys in my kitchen. And it's a pretty funny one with the kiddos involved. So go ahead, check it out. Thanks for tuning in today. Don't forget to do your CK12 assignment around air pressure as well. And if you have any questions, as always, reach out to me via email.